Hello everyone, welcome to the lesson. Today we're exploring consensus mechanisms in blockchain. Before we get into the details, let's start with a quick quiz. Which of these best describes consensus in a blockchain? Is it A, a voting mechanism where blockchain users decide which cryptocurrencies to support? B, the process by which network participants agree on the validity of transactions and the current state of the blockchain? Or is it C, the method used to encrypt transaction data before adding it to the block? All right, go ahead and pause the video for a moment and type your answer in the comments below. All right, ready? The correct answer is B. Consensus is all about how participants agree on which transactions are valid and what the current state of the blockchain is. And to understand how that works, we need to look at two key pieces, Sybil resistance and chain selection. Let's get it. We'll be breaking down how consensus works by covering two key components: how consensus protocols use Sybil resistance to prevent attacks, and the rules they use for chain selection to decide which version of the blockchain is official. A key part of consensus mechanism is something called a Sybil resistance. In simple terms, this is how a blockchain prevents an attacker from taking over the network by creating thousands of fake identities. If joining the network were free, one person could just spin up endless accounts and outvote everyone else. To stop that, consensus mechanisms make participation costly, either in terms of resources, money, or reputation. With proof of work, that cost comes in the form of computation. Miners have to solve difficult cryptographic puzzles. It's like a lottery where every guess burns electricity. To try and cheat the system, an attacker would need an enormous amount of energy and hardware, which makes a Sybil attack impractical. And proof of stake, that cost is financial. Validators have to lock up tokens as collateral. If they behave dishonestly, the network can take away their stake, or a portion of their stake. Imagine putting down a huge security deposit on an apartment. If you break the rules, you lose the deposit. The more tokens you want to control, the more money you risk. Finally, proof of authority. Proof of authority relies on identity. Validators are chosen based on their verified real-world reputation. In this model, it's like a group of notaries or licensed professionals who are trusted to keep records. If they cheat, they don't just lose money, they risk their reputation or even legal consequences. So, in all three cases, the network resists Sybil attacks by raising the cost of participation. Whether it's electricity, staked assets, or personal identity, the system makes it too expensive or too risky for someone to flood the network with fake participants. All right, another important part of consensus is chain selection. This is how the network decides which version of the blockchain is the real one when multiple possibilities exist. Think of it like a group of people trying to agree on which story to keep when different drafts are floating around. The network needs a clear rule to break ties. With proof of work, the rule is the longest chain. But longest doesn't just mean the most blocks. It means the chain with the most total computational work behind it. Since miners have to burn electricity to add blocks to the chain with the most accumulated work is the most secure. And that's the one the network follows. You can imagine this like two competing trails in the snow. The one that's been walked on the most is the one that people naturally trust to be the main path. And proof of stake is not about electricity, but about stake weight. The network adopts the chain with the most staked value supporting it. Here, it's like voting with money on the line. The branch that has the most financial backing is considered legitimate. With proof of history, the method is different. It uses a built-in clock to order transactions, so there isn't really a longest chain competition. Instead, the system agrees on a timeline in advance, which makes it easier to establish the correct sequence of events. You can think of it like everyone syncing their watches before a race. Since time is agreed upon, there's no confusion about who crossed the line first. So, chain selection ensures that even if forks appear, the network has a consistent and fair way to decide which path to follow. All right, we've learned a great deal today about Sybil resistance and chain selection. Now it's time to put your learning to the test. Pause the video. Choose one of these topics and describe it below in your own words. Thank you for watching. Let's keep learning though. Head over to our website to get the full lesson and take the quiz to test your knowledge. The link is in the description below. See you next time.